what you're talking about. 7 over x, everyone knows the graph of 7 over x. Everyone. So as x approaches 0 from the left, of course, it's negative infinity. As x approaches 0 from the right, it's positive infinity. We discussed this function many times. But assuming you don't remember the graph, this should be carved in stone, but assuming you don't remember the graph, you know that a number over 0 has these 3 options. You can never say anything else, not 0, not 5, not 2.3. These are the only options. The problem is that if this had just plus, I didn't have to discuss both. If this had just minus, I didn't have to discuss both. But it does not. It does not have plus. It does not have minus. I am forced to determine the left and the right limits. Because if these two are both infinity, I cannot write dne. I have to write infinity. If these two are both negative infinity, I cannot write dne. I have to write negative infinity. But it happened that one was positive, one was negative, so I have to write dne. But I need to determine both before I write dne.
What's going to be possible if it's only from left or from the right?
If I'm asked to determine from the left, I don't have to calculate anything else. I calculate only from the left. Why would I calculate from the right if I'm only asked to calculate from the left? It will be a waste of time. But here, go ahead.
That's going to be exist, or what I'm going to do? It's going to be
from the left is negative infinity. From the right is positive infinity. From either side, it's dne. Is that better?
No, my question is, it's only one side. If I am going to ask it only from negative, I'm going to write only a negative infinity?
Absolutely. You only determine both if you have from either side. And only if you have a number over 0. Is that okay?
Yes.
Perfect. Let's move on. You can choose, of course. You can ask any questions. Let's look at some differentiation now, which we already just did. But I like to also look at the average revenue, cost, and profit. So let's take a look. So given the revenue, so let me copy this. The revenue, so this is 39 on page 191. Let me also copy these two. I'm hoping, so this was 20, this was 21 on 191, and this was 22 on 191, because I'm hoping that, I always hope that my students will go back and redo these problems. Okay, so for 39, we are given the revenue as 50x. We are given the total cost as x to 2/3 plus 750. And now let's choose. What would you like to determine? Let's not determine all of them because I'd like to review other things too. So x is the number of units, and everything else is in dollars. So the average revenue, the average cost, the average profit, and the rate at which the average cost is changing when 8 speakers are produced. So let's just do the average cost. It's up to you. But I would like not to do all 3, unless you want to. It's up to you. I'd like to go back and review other things.
Average cost.
Average cost, because it's also asking us for x equals 8. Good. 8 units. So why does this appear all the time? So maybe Okay, okay, fine. I deleted it. So the average cost function is C of x over x. We had all these functions. We talked about them. So the average cost. So then this will equal the cost function, which is x to 2/3 plus 750 divided by x. Remember what we do when we have one term. Can anyone refresh our memory what we do when we have one term in the denominator? What do we do? Anyone?
Do we turn it into like x -1 or?
So I think you're on the right track, but what is the idea? What is the procedure? Only when we have one term in the denominator. That's the only time that works. As I said, I always hope, that's my hope, that my students always redo first thing the problems we do in class.
Like, do you want us to simplify? Like separate them?
Yes, thank you.
Simplify?
Thank you, thank you, thank you. So x to 2/3 divided by x, and this is possible only when the denominator is one term over x. So then 2/3 minus 1 is x to -1/3, and plus 750 times x to -1. So this is the most I can do. So now they're asking us to find the rate of change. Rate of change. By definition, that will be C of x over x prime. So this function, but differentiated. Can anyone differentiate this function, and then I'll write it here?
I have a quick question.
Yes.
Where did your x in the denominator go when you had x to the power of 2/3 over x? How did you get x?
X to power n over x to power m. Copy the base, subtract the exponents. From the exponent of the numerator, I subtract the exponent of the denominator. From 2/3, when I subtract 1, I get -1/3. And here it's a different rule. So x to power -n is 1 over x to the nth power. And if I have 1 over x to the nth power, I can change it into, like I had 1 over x, I can change it to x to -1.
Yeah, okay, thank you.
Very good. So then this is, I'm going to skip this, but I don't want to write it again. That's how lazy people do it. So this continues here. So can anybody differentiate this?
-1/3.
Awesome. X to
x to the power of 3 minus 4/3.
Excellent.
Minus.
Very good. 750 times x to
-2.
Awesome. Brilliant. Excellent. Excellent. So now they're asking us to find C of x over x prime when x is 8. So I'm going to plug in 8, but of course I'm going to do it with a calculator. So here's my calculator. Clear whatever you have. So I'm going to, this is my preference. Okay, you may say, I don't want to put it like this. It's up to you. I want to see the function, but that's me. Because later on they may ask me something else. Just plug in something else, and I already have the function in there. X power, in parentheses, -4/3. Close the parenthesis. Come down from there, negative, or the operational negative, 750, and then x, and the power, in parentheses, -2, and close. I'm looking to check Negative 1/3 must be in parentheses. The beginning negative has to be the symbol, not the operation. Negative. X, negative 4/3, minus 750 to power n. Now all I have to do is boom, boom, and plug in 8. Done.
How can I differentiate when I write down if I can ask you a question?
Say that again, Tess. I didn't get it.
How can I differentiate this? Is a simple and the negative or the minus or the...
Oh, so your question is, how do I know when to use this and when to use this?
Yeah, it's on a calculator.
Okay, so very good question. So see, this is the first thing I do. The first thing I need to write. Every time it's the first thing, it has to be minus, this minus. Also, if I have, see, a power like this is not an operation. It's just a symbol. I don't have 5 minus 2. So see, if I want to write 5 minus 2, I write like this. But if I want to raise 4 to power negative 2, it's not an operation. It's a symbol. You see the difference?
I see now.
So when I want an operation to be performed with a negative, it's one thing. But if I only want the symbol to be there, I have to use this. So here at the beginning, there is no operation. It's just a symbol that has to be put in. There is nothing else in front. But if I had here 5, I would have not used this. I would have had to use this. Better?
Yep, thank you.
Perfect. Good. So I go boom, boom. I plugged in 8. Go back to highlight the entire number because it may be truncated. So it's 11.74 with negative. Negative 11.74. And this is, what is the measurement unit? Can anyone give us the measurement unit here? And be very careful. It's a rate of change.
I think dollar per unit.
That's absolutely true. Thank you. Okay. Where is my book? Here. Would you like to differentiate anything else from here? We did a lot of differentiation. So I like to, we can come back, but I'd like to go back to our chapter test and see what we need from there. What about demand and supply? What about demand and supply? Let's see if also the review, there is a big review always here. Okay, economic equilibrium point. How do we determine that? So I have demand and supply. And it's P equals Q minus 7 squared. And P equals Q squared plus Q plus 4. And it says assume that Q is less than or equal to 7. Okay. So we're asked to find the equilibrium point. How do we proceed?
Can you go back to the graph on the textbook really quick?
Yes, it's not relevant, but sure.
Is the in hundreds not relevant?
I say that again.
Where it says quantity in hundreds, is that?
Oh yeah. The moment we write the measurement unit, if we need to, sure. Yep.
Okay.
So it's units and dollars. That's always the case. Good? So how do we start?
T is equals to P, then we're gonna.
Very good, awesome. So Q minus 7, everything squared has to be Q squared plus Q plus 4. Can anyone give us this?
Q.
Q is squared plus.
Mhm. Go ahead.
Maybe you said it, but I didn't hear it.
Plus 14Q.
Yes, but it's minus, correct. And plus,
Plus 49.
that's it, awesome. Equals Q squared plus Q plus 4. Awesome, very good. These two go away. I move Q to this side, and I move 49 to this side. So I get Q. How much is Q?
Three.
Good. So then the equilibrium point has 3, comma what? And where do I get it from?
You plug it in.
Good. So let's plug it in. So how much is 3 minus 7?
Minus 5.
Negative 4. Negative 4 squared.
Plus 1. 16.
That's it. Done. What if we invest $3,000 quarterly for 20 years? And the interest rate is 2%. How much do we get at the end of the 20 years?